Hello, everybody. My name is Argentov, and I'm an aging geek, and I'm a very lucky geek because with time I learned how to sell my hobbies. I basically had two hobbies. A while ago, I started to do computer programming and still make it for a living in Evron company. And also, I'm thankful to FBI conference for having me here. Okay, it's me when I was working in an internet providing company back in northern Russia, in city of Tver, which is a couple of hours from Moscow north. And as always, in a small ISP company, I had to do everything by myself. I was architecting IP, I was doing all that RIPE NCC, bureaucracy. I did some hardware setups. Here's the Cisco system, some Cisco system thing. And of course, with those red eyes, I was working overnights to make some software to force those big things to work. I did parts of a corporate billing system, and while doing that, I was trying different instruments. You see here the big C letter, the white lambda, which is for scheme, and you see here the true and only faith of Haskell, and the incorrect camel there, because that's Perl camel. I was writing in Perl for 2 years, doing some system automation for the gas stations, and that really got to me, deeply. And I've decided finally to find a language which I could use for small and fast things. In those years, we had equipment that was the beginning of the century, and the hardware we had was rather small. For instance, my boss would give me a box with 16 megs of RAM, saying, "Here's your server, do everything you want with it." And you're not limited with what you want to do with that. So I had to find a language which could help me doing correct things on that thing. And I was already full with C, and everything functional we had at that time was in such a pity state. For instance, GHC, those times, was a huge thing which made a big C source with macros from Haskell code, then compiling it to something with such a big footprint that you couldn't use that on the hardware I had. So finally, after selecting between several choices, I've found this thing, and this thing was already working. And it allowed to build a fast and compact output. I've wrote a bunch of software in OCaml in early 2000s. Then I've forgotten the thing. Then I've switched to web development, to Ruby. Then I've came back to OCaml world in order to find what's happening there. And I found that things changed dramatically because in OCaml, to the time I got back to it, they already had OPAM, for instance, the package manager, which could make things, make packages. So that already was not just a good language, but a good language with pretty good instrumentation. Let's go. further and come to the theme of my talk. It's unikernels. Back in early ages of computing, you know, there was an idea that everything you run on a piece of hardware should be an operating system. If you remember MS-DOS and things like that, you know that those tiny resident file system monitors called operating systems were quite popular, and we didn't have anything else. Later, when the years passed, when the virtualized and para-virtualized platforms made its life, some guys found that the idea of bundling all software in a tiny thing, which would be an operating system for itself, is a good idea. Here's the classic picture of the unikernel architecture. So, by the way, the thing which was invented was called unikernel, which means the one thing which is a kernel to itself. So here's the classic layout of the unikernel. On the left, you can see the traditional virtualized thing on a cloud. You see the host part here in grays. You see the guest kernel in yellow, and then green and blue parts are the software you install in a typical cloud container to run your actual code. You see the support software and the app code on top of it, which solves your problem. Of course, now we have a bunch of things to accomplish, such as setup and big cloud platforms made the deployment really easy. We have now the containerized things like Docker. We've got less containerized but still self-contained services like Amazon Web Services, which can pack the thing for you and run it in the cloud. But the idea the unikernel authors come with was still make a really compact, probably fast, and of course secure thing, which would run on top of the virtualizer. So unikernel itself is a three things in one. It's a framework in which you write your software. I, for instance, use MirageOS, a very good thing, which itself is kind of a framework. It's opinionated. It has its own conventions on how to call things and where to place them. Still, it makes a running things as a result. Also, when you compile the whole source, you've got a binary image, which is self-contained and is being run as the complete container you have to work with. Okay, and one of the most, last but not least, as they say, meaning of the unikernel is it's a library operating system, which means everything you do in your code, you define the dependencies, you write the code, you call the functions and stuff, and finally it works as a library code which compiles into your binary as a library operating system. Let's go further. There are, to date, there are different kinds and names in unikernel world. It's, for instance, ClickOS, which is, by the way, there's the site where you can find everything of these. They've got ClickOS, which is written in C++. They've got CLive in Go. They've got Helm, or I don't know how to pronounce it. Helm, the praised Haskell GHC port, which makes a unikernel. One of the best unikernels out there is this one, Ling, which is written in Erlang. By the way, one of the best speakers on the unikernel is the author of this thing. And you can Google it up and find that man and find his talks. They are awesome. One unikernel here, also this, by the way, this is Ling's mascot. This is the logo of RampRun. It's a very interesting unikernel system, which is actually a port of NetBSD, in which you can compile and bring together any kind of software which runs on NetBSD, for instance, Nginx with something under it, and it will compile the whole thing into a static binary and then run it on the virtualizer. Yet it will stay the good old school NetBSD compilation, but with only needed drivers and with only the needed software. And of course, last but not least, and here's its logo, as far as I know. Maybe they will eventually invent something better. But this is MirageOS. This is my favorite one because OCaml is my favorite language. And it was probably the first unikernel system which was not to say production ready. It's another question. I believe we will have time to discuss that. However, MirageOS is a mature unikernel system and mature library, which has everything on its own, the complete TCP IP stack, for instance, and I/O libraries and stuff. Let's go further. Here is the, let me see, what's here? All right. Here is the diagram of how the unikernel is being isolated from the host. The unikernel here is this. The host operating system is here. The hypervisor is here. And the monitor process, which is actually the thing which runs the virtualized virtual machine, is this, the monitor process. You can see that monitor process, it's quite common thing in virtualization. The monitor process does actually two things. It makes setup of the whole thing. For instance, it opens the file handles, the network sockets and stuff. Then it tells the hypervisor to load the unikernel or the virtual machine, if we speak of virtual in terms of virtual machine. It loads the unikernel, and then the monitor process is doing exit handling. For instance, everything which unikernel or the virtualized machine does with the host or with the input-output and things, network, you name it, it does through the calls to hypervisor. Then hypervisor asks the monitor process if it's possible, if it's allowed at all, is it lawful at all, and then makes the actual call to the underlying system. This brings forth both goods and bads for the unikernels. Goods are, they are isolated. Bads are, You know, this thing when a process calls something which recalls something, gives us the situation where we've got doubled or tripled calls. Sometimes it can be expensive. However, it's rather fast with the unikernels because the unikernel stack itself is quite shallow and works pretty fast. In case of OCaml, which generates its own very effective native assembly code, it's true. Let's go further. Pros and cons of the unikernel thing. I'm just reviewing. Good thing is the tooling, as in Mirage, as it's made in Mirage, because everything is self-contained, everything you've got under your hand, everything works pretty good with each other. It has its own building system, which is built on good old school make thing. The code and the binary is quite lightweight, and it appreciates lightweight coding. When you're doing a compact, small unikernel really micro service, you've got to think in fast and small chunks of logic. And of course, it's isolated, which is by now the best thing we can certainly tell about the unikernels. There are researches of making unikernels as a usual processes in the operating systems and things like that. They proven to be quite a secure way to do services on the host. The unikernel has much less of a attack surface than, let's say, something with Ruby on Rails on board in a Docker container. Cons are almost the same. Tooling as in GDB. You know what the GDB thing is, fellow Haskellers? That's that awful thing which allows you to find what's going wrong with your software. OCaml traditionally has good interfacing with GDB. It generates comfortable symbols which allow you to debug and do things. But in case of unikernel, it's an isolated thing, and you have a very small ability to interfere with it. Yet, MirageOS has an option when you compile it with this special TCP port for connecting GDB to the thing and see what's there. About cloud services, this one is the most important obstacle in the way of unikernels in production. You all know that modern cloud services are built around Docker. So when you're doing cloud services, you either do Docker or you do nothing. Like Linus Torvalds said in his youth, you either write microkernels or you write nothing. So he cursed that and wrote us Linux. And double virtualization problem, the third, which I've spoken about a while ago. Okay, I've got very small time left, so I will now entertain you with the toy which I made for this presentation. So first of all, when I've started talking on unikernels in conferences, the guys in St. Petersburg asked me if I can run this on some tiny hardware, for instance, on Raspberry Pi. I said, well, it will be probably possible then 3 years passed, and finally it is possible because Linux for Raspberry Pi for ARM64 platform now has the kernel now has kernel virtualization machine, the KVM interface, and you can do those toys with it. So you can start a KVM virtualized thing. So when I've chosen these things, you can see here. Yes, some people wanted me to do things on a small device, so I decided to buy a small device. Actually, I have 4 of them at my home. I'm training with these things there, and finally I've chosen a Raspberry Pi 3B, which is here. It's blinking with its green eye. This one here, excuse me, it's the wires are short, so it's all working here. And let's go further. There is a Hypriot, or how it's pronounced, operating system, port of Linux for Raspberry Pi, which is container native. I've got a lot of experiments with Docker at home, so this operating system was my choice because I already knew what to do with it and how to patch it in order to make what I need. Also, I needed to build the whole thing. I needed Docker for Mac and VirtualBox because I had to remake the operating system, and the tools which are used for that, they are all open sourced. They need VirtualBox and Docker for Mac to assemble the whole thing, the operating system. Here is the repository I've forked to make my own with the patched sources. Here is mine. Here is Dieter Reuters. A very good build of 64-bit operating system for Raspberry Pi. May play with it. And I've also forked his kernel tuning repository, let's say, or kernel build repository. I forked it and did some tuning there, like these listed here, but it's not the whole config. The whole config is rather big. This, actually, this big, if we compare it to this screen. And it lists the basic KVM switches you need to build the virtualizer. Well, let's say I've built the operating system and even booted it, and it booted smoothly. Here is the source tree for the unikernel itself. Some basics are shown here. Every unikernel in Mirage ecosystem has config.ml and unikernel.ml. By the way, I've decided to make a tiny web server which would serve and is now serving this presentation you see. So the presentation you see is being served right from that toy on the side via the Ethernet cable, and shows us this beauty. Well, config.ml holds the configuration for the framework, and unikernel.ml holds the code which will be run. Here's the config. Later, if you want, you can come by me, and I will explain you what's here. Here is the small last part of the source file, which defines the it's OCaml, which defines the HTTP serving part, the serving function, and it has some code above it. I even have some parts of them here. Here's the config you see on the left and part of the code on the right, just to show you that the whole thing fits in 70 lines of code. Quite compact. Here's the build process. I've made the slides for that. I'm not sure it's very interesting, but just to illustrate that the whole process took about one night to write up and play with it. But if you want to do experiments with MirageOS on Raspberry Pi, I must warn you that Raspberry Pi is a slow compiler. Your compilation will take ages. For instance, the standard OCaml switch takes about 2 hours to build. Then it takes about 1.5 hours to build the dependency libraries to build the final unikernel. Unikernel compiles fast. There are only two sources in there. Here's the artifacts we have after compilation. It's the tiny and small. You see these big, a tiny monitor process, which will actually start the thing and do what you saw on the slide earlier. And here is the binary itself with the file system containing the HTML and site internals built into it as a static binary. Here's the way. Here's the preparation for the operating system, the host operating system to run the thing. You make a tap interface and bridge interface to make the TCP stack available. And finally, you may want to write this kind of systemd service, which would run the thing. Here's the here is the command line which starts. So finally, we have this beauty, the output of the logger, and you can see the loader here, and the log of the tiny web server compiled in. Thank you all. My Twitter is here. My GitHub is here. My workplace is here remotely. And I thank you all for having me here. If you've got any questions, you're welcome.
Thank you, Pavel.
Oh.
Yeah. Questions? No. Maybe you think? No. Okay.
I've left. If you know, I've left out many technical parts. So if you're interested in some technical moving parts, I can explain them as well. But I'm afraid to be off time. So.
Okay. Thank you for your presentation. It was beautiful, as you said. So the question is: this unikernel efforts looks like I don't know, embedded real-time OSs.
Mm-hmm. Exactly.
Yeah.
But
So,
for virtualized platforms.
for example, FreeRTOS and so on. And are there any efforts in collaborations between embedded world and the unikernel world?
As far as I know, not yet. The best they could do was the thing which I've shown you. It can run on a small thing, but still in virtualized environment. The problem is to make the unikernel really compact. It lacks much of the hardware interacting components. It doesn't have, for instance, MirageOS doesn't have interrupt handling, doesn't have core handling, doesn't have file handling itself and things. So it has to be virtualized just to run.
Yes, but I was talking about tooling and so on, because the tooling will be quite similar for both cases.
Probably, but I've never worked with the real-time systems.
Got it. Thank you. But very much.
Not at all.
One question.
Okay.
What is the reason to have this unikernel application in the time when hardware is not more an issue? I mean, hardware is powerful enough to have like JVM on the tiny hardware and run.
Of course, if you've got enough money, you've got enough memory and things.
Yeah,
of course.
but it's not issue anymore in our time.
Well, first of all, the unikernel project already started at the time when the hardware wasn't a problem. So I think basic reason for things like Mirage was the work on security, because due to its architecture, the attack surface is tiny. For instance, in paravirtualized variant, which I shown you, there are only 8 system calls being made, and 8 system calls available to the unikernel through the virtualization system. And there are some works on this which make the surface even smaller with the better monitor processes. So basically now it's probably the security and probably making of those really tiny nano micro services which are really micro, probably. Yet the problem stays that there aren't enough instrument to make probably unikernel would be good for because it has a very fast booting time. Probably it would be great for the what's the word, serverless things and lambdas like in Amazon services. But there are already solutions which do it better and faster. So probably the security would be the catch-up thing.
Thank you.
Not at all.
Thank you for the talk. You mentioned there is the compiling time on the Raspberry Pi was awful. So we're
It's not awful, just long.
Yeah, I mean, still not you know, not you know, inspiring. Anyway, what is the state of cross compilation? You know, it's something that
As far as I know about OCaml, none.
Oh, okay.
It's but OCaml's.
So it's just only OCaml wise, is it?
If the unikernel system is built over C or Erlang, probably there is the way to cross compile at least on the stage of C code.
Okay.
OCaml itself is a language which compiles on everything which you can imagine.
Right.
So maybe because of that, the people behind OCaml are that long in making cross-compiling efforts. Probably. I can't judge, but to add to this, at least OCaml thing, it's possible to compile OCaml software on a tiny hardware which has only 1 gig of RAM and several gigs of disks. A friend of mine tried to do the same thing with the Haskell, and he didn't succeed. He used cross-compiling. I've heard that worked for him.
The cross-compiling there is still in progress. Okay, so is incremental compiling a thing in there? I mean, like it takes 2 hours to build the whole MirageOS, but your business logic at least it wouldn't take these 2 hours again, is it?
I haven't heard about that. Probably you can make your logic, available for compilation as a whole.
It's
as a whole thing.
the matter of iterating fast, since the cross-compiling is not very much available.
Anyway, this one is a toy project,
Right.
and basically unikernels are planned as a software for the Intel cloud platforms.
Yeah.
For Zen cloud platform. For instance, Mirage itself started as a daughter project of the Zen laboratories, and they've made it for itself. By the way, a bunch of code from Mirage is still used in Docker desktops for Mac and for Windows. They've got a lot of good libraries made over time, so so they are using that.
Got it.
Thank you for
Thank
the
you.
question.
I guess that's it. Thank you.
Thank you.